Hello again. So today we're going to be working on some data structures that you'll use in your game. So right now we've gone over the primitive types, which consist mostly of your ints, your strings, your doubles, and whatnot. So we're going to use those primitive types as objects right now. And once we use those primitive types as objects, we can arrange them in specific orders that are going to be helpful to us. The three things I'm going to talk about, or four, is linked lists, arrays, stacks, and queues. And that is a lot, that's basically the entire course of computer science in one video, but we will get through this introductory video and then we'll learn more in depth on how to use these data structures in the game. So let's first start off by I'll show you an example of a linked list, which is something you'll use probably for basically all of your movement and whatnot in a pointer VR setting in a second, yes. That dreadful time it takes for the thing to load. And yes, this is a face of mine, with the 3D scan and whatnot. But so whenever I press M or N, if I press M on this, I move. If I press M again, I move again. But if I press N, I move back. The way you do this is through a linked list, which is a linked list of transform positions on the Unity space. And I'll show you an example in code right now. Right here is how you declare a linked list. It basically starts off with system.collections.generic linked list, and we have it set to vector 3s. Now, a vector 3 is basically a transform with its position. As you can see right here, I declared a number of positions and as transforms. And basically a transform is an object relative to its position. And in order to keep this with polymorphism, I'll show you right here. It's right here. I defined them right here by dragging and dropping into here. So basically, when we get to there, it's as simple as defining that up here, making sure that your linked list is consisting of vector 3s, which basically starts off with vector 3s, and then it goes to places. That's the name of it. I called it places. And you have to create it as a new linked list vector 3. This thing basically means that it's a vector 3, not an int, not another type of object. Now this is your regular old array. Now arrays are pretty simple, but they can only hold integers or your primitive types. So I have one made of an int right here. Public int with these two brackets right here, and I named it placer equals new int with these two brackets right here, and it can hold 10 spots only. While this is infinite, this can only hold 10 spots, and that creates a problem if you don't know how big you want your list to be. Stacks and queues I'll get into another video, but this is how you put things into your linked list. I added these places.add first for the first one, start position.position. It's good to have a vector 3 because start position is a transform, and you cast it to a vector 3 by putting dot position, and that gives you an x, y, and z value for where to go. And there are 9 x, y, and z values for position, rotation, and scale. So this is the x, y, and z value for position. And when you add the first one first and add all the rest last, you add it in a specific order that can be traversed both ways. Meaning that when you add first, you start off with this one, and as you move from position to position, you add last each and every time until you have the full thing. And this right here is a startup debugger that makes sure that you go to your first position first. So the game object.transform.position equals places.element at index. Now, in order to use a linked list as an array, you have to do a dot element at. When you do a dot element at, you have it as an index starting from 0 and going to infinity. Right here is when you first put it in. You put all these stuff in at the start. But in order to do M and M, for instance, if you put M down, and if index less than place count, we have to make sure that it stops at 0. It doesn't go any lower than 0. Index plus plus. This basically increments the index to go up every time you press M. And as you can see right here, I have another one of these things that says specifically to go to that index at that position. But if you press N, it does basically the same thing, but checks if it first is not bigger than the actual list, and then it de-increments it with the minus minus, and also tells it to go to the exact same place. Now this right here is a simple example of a linked list, but it's very good for using positional things, or basically any version of objects you wish to cast into a traversable list that can go backwards or forwards, like I showed you. In the next episode, we'll talk about stacks and queues, which are used for moving in a different way that's also useful and more efficient on the computer. I'll see you next time. Bye.